Today I would like to take the topic of coordinate geometry, and in that the topic is going to be straight lines. First we will be taking that, and we know that in straight lines basically we have got two important concepts. That is, first one, if we come to the basic formula, that is the distance formula. In case of distance formula, if we take the distance between 2 points, if we consider P and X with the coordinates x1, y1 and the coordinates of Q, x2, y2, if we take, then the distance from the point P to the point Q, that is given by PQ, that is equal to the square root of x2 minus x1 square plus y2 minus y1 square. That is distance formula. Then similarly, there is one more important result, that is the section formula. Coming to the section formula, we have what? Suppose we take so 2 points. If I take like P and Q now, P and Q are the 2 points. So now in between P and Q, suppose R is some anywhere in between P and Q. Now suppose R divides the line joining P and Q. There are two possibilities will come into picture. If we come to the first case, that is, if the point R divides the line joining P and Q internally in the ratio m is to n, then the coordinates of the point R is given by the formula m into x2 plus n into x1 divided by m plus n, and the y coordinate is given by m into y2 plus n into y1 divided by m plus n. This is in the case of internal division. Now, instead of internal division, if the point R is dividing externally the line segment PQ, then the formula slightly changes and the formula comes out to be mx2 minus nx1 divided by, instead of plus it becomes now minus m minus n. Similarly, for the y coordinate also, it is going to be my2 minus ny1 divided by m minus n. So we can see that plus sign becomes minus sign everywhere. That is the only change we have got for external division. And now suppose the point R is located exactly middle of the line segment PQ. Then R becomes the midpoint of the point line segment PQ. Then we have got the midpoint formula, and the midpoint formula is given by the midpoint of PQ is just to take the average of the x1 and x2, that is x1 plus x2 by 2, and the y coordinate is given by y1 plus y2 by 2. So these are the fundamental concept of what we will take in the basics of coordinate geometry. Now coming to that, in addition to that, there are few important definitions that we have to see in straight line before taking the straight line concept. That is, let me take a triangle. So let us consider a triangle ABC. Now with the vertices A x1 y1, B x2 y2, and C point with coordinates x3 and y3. Like this we'll take. Then we are going to discuss four important terms that comes in case of a triangle that we will see first. Now first I would like to take the concept centroid. So if I take this term, what is centroid? Centroid is actually, it is the point of intersection of the medians that we draw. We can see in the diagram here. So three vertices you take A, B, C. From the three vertices, draw medians to the opposite sides. So therefore, from A you draw a median, from B you draw a median, and from the point C also draw a median to the side AB. Now the point of intersection is going to be called as centroid of the triangle, and in general it is denoted by the capital letter G. So that is the centroid, and it is given by the formula x1 plus x2 plus x3 divided by 3. That gives the x coordinate, and the y coordinate is obtained by y1 plus y2 plus y3 divided by 3. This is the formula to get the centroid of the triangle. And one more thing, important thing in case of centroid is that it always divides the, if you take the median, if you take the centroid G, divides it in the ratio 2:1 always. This happens in general in case of any triangle, it is going to happen. So that is one of the important characteristic property of centroid. Now, similarly, three more terms I would like to discuss here. The second term is orthocenter, and it is denoted by the capital letter H. What is orthocenter? Please see, students, that orthocenter, it is the point of intersection of the altitudes. That means from the three vertices, if you take here, so from the vertex A, drop a perpendicular. Here earlier case we have drawn the median. Median means it is the midpoint of the line segment BC. However, here when we take, we have to drop a perpendicular from the point A to the line segment BC. Then again from the point B drop a perpendicular, and again from the point C drop a perpendicular to the line AB. Now you will get the point of intersection. This itself is called as orthocenter, we call. And if we take orthocenter, it is just simple. How to find orthocenter? That is very important now. To find the orthocenter, first of all, we have to get at least two equations of the altitudes. Either take, suppose I take this altitude and the second altitude, these two, if I take, find its equation first by any of the methods that we can use in straight line. After finding the equation of the two altitudes, solve them by using any of the method of solving linear equations. To solve those two, you are going to get the coordinates of the orthocenter of the triangle. That is the method we have to adopt. Now, coming to the next term, that is in center. So in center and next one circumcenter, these two are the words that you might have used in your lower classes. But when we come to this concept, how we are going to define that again, once you will recall that now. So now, what is in center? In center is nothing but you take the angular bisectors of the three vertices of the triangle. That is vertex A, B and C. For them, get the angular bisectors. They will meet at a point. With that point of intersection, that is called as in center. With the help of that point, we can draw a circle inside the triangle which touches all the three sides of the triangle. So you can draw a circle like that. So that is the point of intersection of the angular bisectors, that is called as in center of the triangle. And how in center is calculated? In center, suppose the coordinates are x1, y1, here it is x2, y2, and here it is x3, y3. There is a direct formula to find the in center of the triangle. It is given by, I'll write here, rather the formula I am going to write here, that is a into x1 plus b into x2 plus c into x3 divided by a plus b plus c. This is going to give the x coordinate. Now you may ask, what is a, b, c? A is nothing but the length of the side of the triangle opposite to the vertex A. That should be taken as A. Then opposite to the vertex B, this length of the side AC, that is B. And opposite to the point C, so this you have to take it as length of the side C. So that corresponds to ABC. Now similarly, the y coordinate is given by a into y1 plus b into y2 plus c into y3 divided by again a plus b plus c. So this is going to give you the in center of the triangle. So this is the next third definition. Coming to the last definition, that is circumcenter. What is circumcenter? It is usually denoted by the capital letter O, and it is defined as, it is the point of intersection of you take the perpendicular bisector of the three sides of the triangle. So when we take the perpendicular bisector of the three sides of the triangle, what you get? The point of intersection that itself is called as the circumcenter, and again with the help of that you can draw a circle which passes through the three vertices of the triangle. So this is called as circumcenter of the triangle. And in circumcenter it is going to, you can see only how to find it, that is very important. To find the circumcenter, first of all you can note down that this is we are going to draw a circle here, and from this you have to draw a radius here. OA you can find OB and OC. OA equal to OB equal to OC. Suppose you take the coordinates as x comma y, then take OA equal to OB and then take OA is equal to OC. You can get three equations and solve that, you will get the circumcenter. Now regarding the main terms what I have explained, one or two important points we have to note. They are, as I have written here, see, note number 1, if you take any equilateral triangle, then GHO, G stands for centroid, H stands for orthocenter, O stands for circumcenter. All of them are going to coincide. Even in center also, all the four what we have taken the points, all of them come together and they are going to coincide in case of an equilateral triangle. And point number 2, if you take a right angled triangle, in any right angled triangle, the circumcenter is always going to be the midpoint of the hypotenuse, and the orthocenter is always going to be at that point where we are having the right angle, that is going to be the orthocenter. And last point, that is the orthocenter, centroid and the circumcenter are always collinear to each other, and the centroid always divides the line segment joining the orthocenter and the circumcenter in the ratio 2:1. This always is going to happen. And there is one more important term that comes in coordinate geometry, that is locus. What is locus? It is the path traversed by a moving point satisfying a certain condition or more than one condition. A simple example is a circle. What exactly is a circle? If you take a point, it moves in such a way that its distance from a fixed point always remains a constant. Then that path traversed by that moving point is nothing but that is going to give you the locus of that, which is called as circle. And now coming to the main concept of what we say, the coordinate geometry in straight lines, that is the slope of a straight line. What is the slope of a straight line? Suppose if you take a straight line and if it makes an angle theta with the positive x-axis, then slope denoted by the letter m is given by tan of the angle theta with respect to the positive x-axis. And one more way we can find slope of the line. Suppose you know 2 points on the straight line, x1, y1 and x2, y2. These are the 2 points on the straight line. Then its slope can be given by y2 minus y1 by x2 minus x1. Like this we can find out. Now coming to some of the standard forms of equation of a line. Now the first form is a point slope form of a line. Suppose we know a point on the line. Suppose its coordinates are x0, y0. Then its equation is given by y minus y0 equal to m, which is the slope of the line, into x minus x0. This gives the equation of the straight line. Now coming to the second form, that is a 2-point form. If you know 2 points, as the name suggests, if you know 2 points on the straight line, then it is given by y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. You can please note that this is nothing but slope of the straight line. So that is going to be the true form of the equation of the straight line. Coming to the third point, that is slope intercept form of equation of a line. Now, as the name suggests, if you know the slope of the line and one of the intercept, either it is x-intercept or the y-intercept. Suppose y-intercept is given, C is the y-intercept, then the equation of the line is given by y is equal to m, which is the slope, mx plus c, where c stands for the y-intercept. Or otherwise, instead of y-intercept, if we know the x-intercept, suppose D is the x-intercept, then the equation of the line is given by y equal to m into x minus d. This is going to give you the equation of the line. Now, the next most important form of line, it is an intercept form of equation of a line. For a given line, if we know the x-intercept, suppose it is a, and the y-intercept, suppose it is equal to b, then the equation is given by x by a plus y by b equal to 1. This gives the equation. Coming to the fifth form, that is a normal form of equation of the line. Consider a line, straight line, in that you drop a normal from the origin to the line, and we know the length, suppose it is equal to p, that is the length of the normal, and the angle made by the normal with respect to the positive x-axis, if it is omega, that is the notation if we use, then the equation is given by x cos omega plus y sin omega equal to p. This gives the equation of the line. And last one, parametric form of equation of the line, and it is given by, suppose x and y, these are the coordinates of any point on the line. Suppose I consider a straight line. Suppose P is a point on that with the coordinates x, y, and if a point is given, suppose its coordinates are x1, y1. So this is the given point, x, y be any point on the line. Then the distance from the arbitrary point to the given point, suppose it is equal to r, and angle made with respect to the x-axis is theta. Then the coordinates x and y are given by x1 plus r times cos theta, and y is equal to y1 plus r times sin theta. This is the parametric form of equation of the line. Now, coming to the general form of equation of a straight line, it is given by ax plus by plus c equal to 0, where a, b, c are any real numbers. And in case of when it is given the general form, we can get the slope, then x and y intercept by the formula. Slope m is given by minus a divided by b. Minus a by b gives the slope of the line, and x intercept is minus c divided by a, and the y intercept is minus c divided by b. This gives the basic information regarding the straight line. And coming to, suppose if we take two different lines, two lines a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, then the two lines are going to be parallel. When we say they are parallel, only if a1 by a2, that should be equal to b1 by b2. This ratio should hold good. And suppose if we take the lines and they are going to be perpendicular, when this condition is satisfied, which is a1 a2 plus b1 b2, their sum should be equal to 0, then the two lines will become perpendicular to each other. And next, we'll take some time saving results. Directly we can substitute in the formula, you are going to get the result. The first one is, suppose you take the general form of equation of a line, that is ax plus by plus c is equal to 0. And if you take the equation of any line that is parallel to it, that is in the form ax plus by plus k equal to 0. Only the constant part will be changing, remaining 2 will remain the same. And equation of any perpendicular line to it is in the form bx minus ay plus k equal to 0. You can note that the coefficient of x and y get interchanged and the sign plus becomes minus, or if it is minus here, then it will become plus here. Like that it is going to change. And two direct results I would like to give here. One is, suppose you take any point x1, y1 and let the foot of the perpendicular from this point to this line, suppose it is h comma k is a foot, then it can be obtained by considering this system of equations, that is h minus x1 by a, that's equal to k minus y1 by b, that's equal to minus of a into, just you take this equation, replaced by the coordinates ax1 plus by1 plus c divided by a square plus b square. What you have to do is take the first part, equate it to the last part, then you can rearrange and get h value, and similarly take the second part, equate it to the third part, again by substituting all the remaining values you can get the k value, hence you get h and k value to get the foot of the perpendicular. Again, one more thing is image of a point x1 comma y1. Actually image is nothing but it is at a distance 2 times that of the foot. So quite easily it is also possible, just a small modification in this formula you can get image of a point. Here only I will explain. Image of a point is nothing but same formula, just a small modification. Last part just you have to multiply by 2, you have to multiply, that is going to give you the h comma k, which can be treated as the image of the point x1 comma y1. So ultimately it is going to be same part, that's equal to minus 2 times of this entire value. If we take that equation, it will give you the image of the point. Now coming to the next part, that is the equation of a line passing through the intersection of, suppose these are the two lines L1 and L2, these are the two lines. Suppose you want equation of a line passing through the intersection of these two, then it is simply obtained by consider this L1 plus L2, L1 plus lambda times L2 make it equal to 0. This combined equation gives equation of any new line. Coming to the next point, the ratio in which the x-axis, suppose you take a line, the x-axis is going to cut that. So x-axis divides the line joining the 2 points. You take 2 points joined by that by line, the x-axis will cut. In what ratio it will cut? In the ratio minus y1 by y2. And the point of intersection is obtained by this result. And the y-axis is going to divide in the same way in the ratio minus x1 by x2, and the point is given by, simply make the x coordinate 0, y coordinate similarly you take it in the other side, but divide, numerator is same but denominator is going to be x2 minus x1 instead of y2 minus y1. That is going to give the value. Now I would like to discuss about 2 more important results that comes in straight lines, that is angle between 2 straight lines. So suppose I consider 2 straight lines in the standard form, that is a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, then the angle between the 2 lines can be given by the formula tan theta equal to a2 b1, observe the coefficients, then take it in such a way, modulus of a2 b1 minus a1 b2, or even can take in the other way also, no problem, because we are going to take the modulus at the end, divided by a1 b2 plus b1 b2. This gives the angle between the lines. And suppose if you directly know the slopes, that is m1 and m2 are the slope of the 2 straight lines, then you can give the same formula in another way, that is tan theta equal to mod of m2 minus m1 divided by 1 plus m1 m2. When you take the modulus, you will get the acute angle theta between the 2 straight lines, and the obtuse angle can be given by just taking 180 minus the acute angle, which gives the obtuse angle between the 2 straight lines. Now coming to the distance of a point, you take a straight line, like this, you take a point. Now the coordinates you take it as x1, y1. take x1 y1 as any point. Suppose you want to get the distance of this point to the straight line, then distance nothing but it is going to be the perpendicular distance we are going to find, and it is given by the distance of the point x1 y1 from the line ax plus by plus c equal to 0. It is given by d equal to modulus of ax1. Instead of x, just to substitute x1, here substitute y1, you will get ax1 plus by1 plus c divided by root of a square plus b square. This gives the distance of a point from the line. Now, suppose we have got two parallel lines. Then parallel lines, you know that their x and y coefficients are proportional to each other, and therefore we can reduce in the form like this: ax plus by plus c1 equal to 0, and ax plus by plus only constant changes, c2 equal to 0 be the two lines. Then the distance between them is given by mod of c1 minus c2 by root of a square plus b square. This gives the distance. Now, few more results I would like to get here. That is, you take any two straight lines, intersecting straight lines you take, then the equation of the bisector, exactly you take equation of a line which bisects. There are two possibilities are there. One is acute angle bisector, another is obtuse angle bisector. Now, both equations can together write like this. So, to take two lines, a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0 be the equation of the two lines. Then the together two equations are present here. So the equation is given by this result. Just take that equation, divide by square root of sum of the squares of the coefficients of x and y, just divide by that. Similarly, that is equal to plus or minus, which gives two equations here. Divide by, take the second equation. Similarly, you apply for that, you are going to get the equation of the bisector. Now, as I told, there are two bisectors, acute and obtuse. Now, there are exactly how to find the acute and obtuse bisectors. There is a procedure for that. First of all, write the equation of the line in such a way that you are going to make c1 and c2 positive, so that you may have to adjust with the coefficient of a and b either by multiplying or by minus sign. So make sure that equation of the line is in such a way that c1 and c2 are positive. After that, now take the product a1 a2 and b1 b2, take the sum, that is a1 a2 plus b1 b2, find out. If that is going to be greater than 0, that means, as I told you, you take a1 a2 plus b1 b2. So what we are going to get here, if it is going to be positive, then the equation here with only the plus sign, what you are going to consider, that is going to give you the obtuse angle bisector. So the negative value on what you are going to take, that is going to give you the acute angle bisector. And if it is negative, then it is going to be completely vice versa. Now, coming to another point, that is, you take a line ax plus by plus c equal to 0. It divides the line joining the 2 points. The ratio you can obtain by this formula, that is just to take minus of, substitute x1 y1 once, then substitute x2 y2 once, take the ratio, that is going to give you the ratio in which it is going to divide. Last one point, that is, if you take a point x1 y1 that divides the line segment between the axis and the ratio m is to n, then the equation of the line is given by the formula nx divided by x1 plus m into y by y1 is equal to m plus n. This is directly going to give you the equation of the straight line. These are some of the important concepts that we have discussed here, and with the help of this we can solve the worksheet that I am going to forward. Thank you.